Hold on, today's what date? So assignment due Friday by Shucks. Like I'm a friend. She always gets a link. Pick up. Hello? I'm trying to reach Natasha. Oh hey girl. How you doing? Girl, I trying here myself with these 101 assignments for you to throw upon me. I actually call you for some help. It's one that's based on tectonic boundaries. What do you know about that?
Hi Natasha, not bad. What are you gonna do? We gotta try with it. Tectonic boundaries, no problem. The earth is composed of layers of different composition and physical properties. You have the solid core, the fluid core, and the mantle, and the solid lithosphere. The lithosphere is comprised of the upper mantle and the crust. Together they make up the outer shell of the earth. There are two types of lithosphere. The crust resting on the solid mantle, and the oceanic lithosphere, which is about 5 to 8 km thick and composes mainly of basalt. The continental lithosphere has a thickness of about 30 to 40 km and is mostly made up of granitic materials. The lithosphere is fragmented into pieces of variable shapes and sizes, kind of like a puzzle, the pieces of a puzzle. The pieces are called plates. The edges of the plates are called plate boundaries. The Earth has 7 major plates: Africa, Antarctica, Australia, Eurasia, North America, South America, and the Pacific plates. And there are several minor ones, for example, the Caribbean plate and the Nazca plate. These plates move relative to one another over the asthenosphere through geological time, such that deformation, seismicity, and volcanism occur. Plate boundaries are divided into 3 types. You have the divergent plates, the convergent, and the transform. Now that's the basic overview of plate boundaries. But if you want to know more about these plate boundaries or plate margin, I can put you on to a friend. Okay? Alright, cut.
Hello. Mm-hmm. Oh yeah. Uh-huh. I just hold for me a bit. Plate boundaries. Fair enough. Yeah. So, you listening, man? Alright, fair enough. Yes. So, divergent plate boundaries. Alright. So, basically, there are 2 types of divergent plate boundaries. However, you only need continental. Wise choice.
Those are some features formed. There is a divergent plate margin. Molten rock or magma is forced slowly upwards between the 2 plates, and when hardens, a strip of new crust has been formed. This is a basalt plateau. Basic lava flows to the surface close to divergent plate boundaries, forms as basalt lava flows. Along plate boundaries, faulting can develop continental scale landforms such as the Great Rift Valley in Africa. The eastern part of the continent is being pulled away slowly from the rest of Africa. Where the valley is deep, there are large lakes such as the Lake Matiwi and Lake Tanganyika. The Rift Valley is slowly getting wider, and in 50 million years it could be as wide and as deep as the Red Sea in just 50 million years.
Stay away for too long, don't go.
When divergent plate margins occurs under oceans, it is known as ridges. Ridges aid in a process known as seafloor spreading. These are sites of shallow earthquakes and vigorous hydrothermal circulation. As plates move away from mid-ocean ridges, they cool thermally, contract, and subside. However, they also thicken by accretion of solidification of magma at their base and sediment on the top. Mostly submarine basaltic volcanicity of mid-ocean ridges are found here. Due to low viscosity of the magma, volcanic activities are not explosive. Divergent plate boundaries in the ocean is directly related to and the cause for seafloor spreading. It is also one of the three major zones in the world for earthquakes. It's the Atlantic Ocean and mostly underwater.
Is the continental to continental conversion plate boundary. The continental to continental conversion plate boundary are made when two plates collide. They have a density lower than the mantle, which prevents subduction. So instead, they crunch and fold rocks, lifting them up to form mountains and mountain ranges. A very good example of this boundary is the Himalayan mountain range in India.
Hello, good afternoon. Oh, what's going on? Oh, you want help with the thing with Sir Gibito? Well, I now starting to know. Alright, let me explain my part. Right? Ocean continent convergent plate. This is what we're talking about, right? Yeah, same thing. A convergent plate boundary is a location where two tectonic plates are moving towards each other. You understand so far? Often causing one plate to slide below the other in a process known as subduction. The collision of two tectonic plates can result in earthquakes, volcanoes, the formation of mountains, and other geological events. Yeah. When oceanic and continental plates collide, the oceanic plate undergoes subduction, and volcanic arcs arise on land. These volcanoes release lava with chemical traces of the continental crust they rise through. The Cascade Mountain of Western North America and the Andes of Western South America feature such as active volcanoes. So do Italy, Greece, Kamchatka, and New Guinea. Oceanic plates are denser than continental plates, which means they have a higher subduction potential. They are constantly being pulled into mantle, where they are melted and recycled into new magma. The oldest oceanic plates are also the coldest, as they have moved away from heat sources such as divergent boundaries and hotspots. This makes them denser and more likely to be subducted. No problem.
Don't forget your mask, guys. So, convergent plate boundary, oceanic. The first type of convergent boundary is oceanic convergence. The oceanic crust, which is made up of heavy seama, is drawn downwards beneath the adjoining plate. The area of downward movement is known as the subduction zone. The pushing of oceanic crust below the lighter continental crust caused the oceanic crust to become hot in the mantle. This action causes the rocks to melt. The rocks then expand and move upwards through vents where they form volcanoes. Sometimes, when oceanic and oceanic plates collide, the cooler, denser oceanic lithosphere sinks beneath the warmer, less dense oceanic lithosphere. As the slab sinks deeper into the mantle, it releases water from dehydration of hydrous minerals in the oceanic crust. The water reduces the melting temperature of rocks in the asthenosphere and causes partial melting. The partial melting will travel through the asthenosphere, reaching the surface, resulting in the formation of volcanic arcs. Examples of volcanic arcs are Northeastern Japan Arc, Izu Islands, Bonan Islands, Luzon Volcanic Arc, and the Philippines.
Who's this now, man? Hello. Transfer plate boundaries now. Are you there on quarantine? Alright. Just listen. You're listening to me? Good. Transfer plate boundaries are one of the three main plate boundaries in the theory of plate tectonics. Well, as you know, Each plate boundary is characterized by features that can be observed near or on the Earth's surface. Transform boundaries are when two plates pass each other. They are different from convergent and divergent plates. This is because they do not create nor destroy crust, because they lack the features that are commonly found at the other two boundaries. You know that. However, transform boundaries are characterized by having high volcanoes and also high seismic activity that are spread out over shallow depths. All of the other features in plate tectonics, including geochronology, topography, and bathymetry, have very few distinguished features on transform boundaries. The most common transform boundary known today is the San Andreas Fault, which we all know is in California. These two plates move at about 6 centimeters per year. This means in about 10 million years, the cities of Los Angeles and San Francisco will be side by side with each other. Also, transform plate boundaries are also known to display strange features on their surfaces. These are features such as stream beds or friend lines that have separated over time. I hope this helped you, and please don't call back my phone. I am on quarantine.
Finally, so all of this is saying is that tectonic boundaries are the location where two plates meet. These plates makes up the outer layer of the Earth known as the lithosphere. The three types of tectonic boundaries, convergent, divergent, and transform, collides with, pulls apart from, or slides past each other respectively. Many volcanic and seismic activities occur through the movement of tectonic boundaries. These movements contribute to the formation of many common features such as ocean trenches, volcanoes, mountain ridges, plateaus, and valleys. For example, the Himalayan mountain range was formed from a convergent boundary, the African rift from a divergent boundary, and the San Andreas Fault from a transformed boundary. As the Earth's lithosphere is in continuous motion, it is believed that its continents will again meet and form a supercontinent referred to as Pangaea Ultima.